Magnetism permeates everything that we do in life these days. It affects a lot of what we do. For example, you can think of these in terms of games, learning games. Think of the magnetic field due to the Earth and the way we use that for navigation. Cars, space shuttles, they would not operate they would not operate without magnetism. Electrical motors, credit cards, that's the magnetic strip, the black magnetic strip, computers, they're everywhere. Now, when you think of magnetism at the natural state as a mineral, there is what we call magnetite or a lodestone. That's a natural magnet that you can find naturally as a mineral. Now, other than that, for example, store-bought magnets that are going to look somewhat like this. Sometimes they are labeled with a north and a south. The colors might be a little different from what we see here. Sometimes they might be red and blue. Sometimes we will not have the N and the S marked there. Sometimes it will be just a piece of magnet with nothing marked. Now, one characteristic of magnets is it has a north pole and a south pole. For magnets, like for electrical charges, opposites attract and likes repel, very much like electrical charges. Unlike for electrical charges, we have magnetic field lines. Like for electrical field lines, we have magnetic field lines. And the arrow, like for the electrical field lines, the arrows give the direction of the magnetic fields. Now, what if we break a magnet? What's going to happen? Actually, if we break a magnet, we get two magnets. Each one of them is going to have both a north and a south pole. So breaking a magnet produces two magnets. It doubles the number of poles. We're not talking about strength here. You need to be careful about strength. Strength is a little bit more complicated. You are not going to create more energy by having separate magnets, but in the same token, what makes each one of these magnets is slightly complex phenomena, and the overall effect at the end is going to depend on the particular microscopic properties of each of these magnets. Now, what are these particular properties? If we have a material that we call ferromagnetic,